Hello dear students, in the previous lesson we discussed about the EMF and the terminal potential difference. Now in this example, in this lecture we are going to discuss the questions about this EMF and the terminal potential difference. Okay, now we start. First I read the question, then I will explain. Of 65 ohm, this is external resistor R. External resistor R is 65 ohm resistor is connected to the terminal of the battery whose EMF is 12 volt. Okay, let me write the given information. So the external resistance R is 65.0 ohm. This one, this is the external resistor R that is connected with the battery that has EMF of 12 volt. The EMF is 12.0 volts. Okay, and who is internal resistance is 0.5, so small r is 0.5 ohm. This is internal resistance small r. Calculate the current in the circuit. So for the part A we need to calculate the current in the circuit. Okay, so in order to solve this for current I that is flowing through the circuit, so we use simple Ohm's law. According to Ohm's law, the total potential difference E is equal to current I into total resistance R. So the total resistance is, we know that small r and capital R in series, so R plus R. So V is equal to IR. Simple formula is V is equal to IR, but here V is the total EMF potential and R is the total resistance RT. So EMF E is equal to I into R means the R plus R. Now we solve for I, that is equal to EMF over small r plus capital R. So I is equal to EMF is 12 volt divided by small r is 0.5 ohm and capital R is 65 ohm. So we get answer 0.183 ampere. So this is part 1, part A. Okay, the current in the circuit. Now the terminal voltage of the battery VAB. We need to find in the part B. We need to find the terminal potential VAB across this resistor VAB, across this resistor. Okay, across this from A to B. Okay, in order to find the terminal potential, we use the formula VAB. VAB is equal to E minus IR. So the EMF is 12.0 volt minus current is 0.183 ampere and the internal resistance is 0.5 ohm. Okay, now we solve and we get the answer for this VAB. We just solve VAB, which is equal to, so I repeat again, E is the EMF, I is the current, R is the small internal resistance small r. We have all the values and we just put the values, we get the answer VAB, that is equal to 11.9 volts. Now for the part C, the terminal voltage. Okay, now the power for the power dissipated across external resistance capital R and the power dissipated in the internal resistance R. So for the part C we have to find power dissipated across the external resistance R and power dissipated by the internal resistance R. Okay, so in order to find the power we use the formula P is equal to I square into R. I square. Current flowing through the circuit is 0.183 ampere and external resistance is 65.0 ohm. So when we solve we get power dissipated across external resistance R, capital R, that is equal to 2.18 watt. Now we need to find the power dissipated across the internal resistance small r. So power dissipated across the internal is equal to I square into small r. So the P small r is equal to square. Current is 0.183 ampere square into internal resistance is 0.5 ohm. Now we put the values and we get the answer, that is equal to 0.02 watt. Okay, so this is very simple question. We just need to remember the formulas. Okay, we have all the values and we get the answer. Okay, thank you.